Okay, let's go back to grade 9 for a second and let's examine this word polynomial. Poly meaning many. So many could be, surprisingly, 1, 2, 3, or whatever. 1 we call a monomial. 2 we call a binomial, just like bicycle means 2. 3 we call a trinomial. And what's interesting is that all polynomials can actually be written in terms of x's and y's and so on. But the cool thing is you can also use a model to explain what a polynomial is. This here is called a positive x tile. What do I mean by that? I'll tell you in a second. This one looks like an x squared, doesn't it? And that's why we call it an x squared tile, because it looks like a square. This tiny one here is considered to be a ones tile. So I want to show you something. Notice that this is an x squared tile. The reason why, this side is x, this side is x, length times width, you got an x squared. That's how it works. Now, if you think about it this way now, look at this length. It's the same length as this one. So you got an x by this height, which is a 1. You see it? So that's an x times 1. That's why we call this an x tile. And this guy would be 1 by 1. 1 times 1, that's why it's called a 1 tile. So there's an x squared tile, there's an x tile, there's a ones tile. Now, let me show you something really cool here, okay? If I give you a binomial times a binomial, what do I mean by that? I give you a number or a polynomial that has 2 terms, 1 term, 2 terms. And I'm going to multiply it by another binomial that has 1 term, 2 terms. I'm going to use Algebra Tiles to show you how this works. Okay, so here's how it works. Real simple. I've got x minus 5, and I'm going to take this guy and I'm going to put him down here. So that's where my x minus 5 is going to go. Okay, so watch this. An x is this length. There's an x, because I know x's look like that. Okay, minus 5 means I'm going to take these ones. And I'm going to have 1 here, 2, 3, running out of room here, 4, and 5. Over here now is I'm going to put my other one here. My other one is going to be 2x plus 2. So again, my x's look like this, but now I'm going to write them this way. There's 1x, 2 x's plus 2. 1, 2, because the 2 looks like this. Now, I got to go back and I got to shade some things, because of course, this is a negative 5. So I'm going to shade this to say that these are in fact, the shaded ones are in fact my negative ones. Everything else is positive. Now, this is where the fun starts. Here we go. Ready? Just join the box and extend the lines. Watch this. This is so cool. Keep drawing the lines. Keep drawing the lines. And look at that. We're keeping drawing the lines. And I'm going to draw this line down here. And I'm going to draw this line down here. And I'm going to draw this line down here. But watch this. You know a negative times a positive will give you a negative. So wherever this was here, these are all shaded. That shaded, 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 that shaded. Oh, let's keep it going. Oh boy, here we go. Here we go. All right, so they're shaded all the way across. Now, check this out. Let's add some things together here. If you look at this, this is an x squared tile. And being that it's not shaded, it's positive. Here's another x squared tile. So there's 2 of them. So we can actually say that there are 2 x squared tiles. Okay? Now check this out. This guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all negative x tiles. Look at this. This guy is an x tile. That's a positive x tile. So we add 2 more x tiles to that. And then look at this. We have 1, a negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and negative 10 for a value. And the cool thing is you can combine the like terms. So I'm going to combine this term with this term, and my answer is going to be 2x squared minus 8x, because negative 10 and positive 2 gives me negative 8, and subtract 10. That's my answer for this question right, whoa, back up here for here. So my answer is actually equal to 2x squared, right? Checking my answer again. Negative 8x minus 10. Oh my goodness. Now, you're probably saying to yourself, trying out a factor tree, or I should say an algebra tiles like this, that's kind of insane. That takes forever, doesn't it? Is there an easier way? Yes. A distributive property known as FOIL, which is really, really cool and incredibly powerful. FOIL stands for F stands for first. O stands for outer. I stands for inner. And L stands for last. Let me show you how this works with this beautiful thing we have right here. The x minus 5, 2x plus 2. I'm just going to rewrite it down here. X minus 5, 2x plus 2. Now, let me show you how FOIL works. FOIL, remember the one, says first. The first are the first terms. This guy and this guy. It's the first term of this binomial, the first term of that binomial. So x times 2x is actually 2x squared. Outers, the O in FOIL. The outers means the outer ones. This guy and this guy. Those are on the outside. So what is x times 2? Oh, that's easy. That's plus 2x. Then the I stands for inner. What are the inner two numbers? Well, minus 5 and 2x. So minus 5 times 2x actually gives us minus 10x. And then finally, the last. The last are the last two terms, this one and this one. Minus 5 times 2, which is minus 10. And lo and behold, take a look at this. This is going to really freak you out when you see it. Look at this. There's 2x and minus 10x. They can be combined to give you 2x squared minus 8x, and there's the minus 10 all by its lonesome. Check it out, baby. Look at that. This guy and this guy are exactly the same. So if you want to see a visual representation, this is the way to do it. That's nice visual representation. But you know what? FOIL is really where it's at. First, outer, inner, last. Oh, does that ever help you an awful lot? So let's take a look at one more question in the next podcast and see what we can do and see if we could do it much, much more efficiently.